Imagine a volcano in Europe that plunged the continent into a mini ice age, causing widespread famine, societal upheaval, and a climatic shift so severe it reshaped history. Yet, this catastrophic event is rarely discussed today, overshadowed by more famous eruptions like Vesuvius or Santorini. This is the story of a forgotten volcanic event in 536 CE, a disaster so profound that it dimmed the sun, cooled the earth, and left a lasting mark on human civilization. Ancient texts describe darkened skies, and modern scientific data, from ice cores to tree rings, confirm the chilling reality of this climatic catastrophe. What was this mysterious volcano, and why has its story faded into obscurity? Let us uncover the truth behind Europe's forgotten climate killer, and explore its historical and modern implications. In early 536 CE, a mysterious fog descended over Europe, the Middle East, and parts of Asia, plunging these regions into an eerie twilight. Byzantine historian Procopius wrote, "For the sun gave forth its light without brightness, like the moon during the whole year." This wasn't a poetic exaggeration. It was a first-hand account of a climatic anomaly that modern science now attributes to a massive volcanic eruption. This volcanic winter wasn't caused by a single eruption, but by a series of at least 3 near-simultaneous events, with ash and sulfate aerosols spewed into the stratosphere, blocking sunlight and cooling the planet. Unlike Vesuvius, which famously buried Pompeii, or Santorini, linked to the Minoan collapse, these eruptions have no clear cultural footprint in modern memory. Their sources remain debated, with possible locations ranging from Iceland to Central America. However, their impact on Europe was undeniable. Crops failed, famine spread, and societies teetered on the brink of collapse. Modern science has pieced together the story of 536 CE through meticulous analysis of ice cores, tree rings, and historical records. Ice cores from the Colle Gnifeti Glacier in the Swiss Alps, drilled to a depth of 72 meters, preserve over 2,000 years of atmospheric history. These cores reveal sulfate spikes and volcanic ash layers dated to 536, 540, and 547, indicating massive eruptions that ejected sulfur dioxide, SO2, into the stratosphere. When SO2 reacts with water vapor, it forms sulfuric acid aerosols, which reflect sunlight and cool the Earth's surface. Tree ring data corroborates this chilling tale. Narrow-growth rings from trees in northern Scandinavia and other regions indicate unusually cold summers around 536 and 540, with the decade following 536 being the coldest in 2,000 years. These findings align with climate models, which suggest that the stratospheric aerosol clouds from these eruptions reduced solar radiation, triggering a feedback loop involving increased sea ice and altered ocean currents. This prolonged the cooling, creating a domino effect on agriculture and human survival. Historical texts provide a human perspective on this disaster. In Constantinople, chroniclers noted darkened skies starting in March 536, with summer snowfalls and persistent cold. Chinese and Indonesian records describe similar atmospheric phenomena, suggesting a global impact. While the exact volcanoes remain elusive, candidates include Iceland's volcanic systems, Ilopango in El Salvador, and Krakatau in Indonesia. A 2018 study analyzing ash in Swiss ice cores pointed to an Icelandic eruption for 536, while others argue for a tropical volcano like Ilopango for the 540 event, based on ash deposits in Central America. The uncertainty underscores the challenge of pinpointing ancient eruptions, but the climatic and societal fallout is clear. The volcanic winter of 536 CE didn't just cool the climate, it reshaped human history. In Europe, still reeling from the fall of the Western Roman Empire, the sudden drop in temperatures devastated agriculture. Wheat, oats, and other crops failed across Britain, Ireland, and Scandinavia, leading to widespread famine. Food shortages sparked riots in cities, with hungry populations storming grain markets and bakeries. In Ireland, the failure of potato and oat harvests led to starvation, while in Switzerland, cold summers caused an ice dam to form below the Gietro Glacier, resulting in a catastrophic flood in 1818 that killed 40 people, a delayed consequence of the climatic chaos. The cooling also set the stage for the plague of Justinian, 541–549 CE, one of the deadliest pandemics in history. The famine-weakened population, coupled with cooler, drier conditions, likely facilitated the spread of Yersinia pestis, the plague bacterium. An estimated 25–50 million people died, decimating the Eastern Roman Empire and contributing to its economic and political decline. Some historians like David Keyes argue that the 536 event triggered broader societal shifts, including the migration of Slavic and Lombard tribes into Roman territories, the decline of the Gupta Empire in India, and even the rise of Islam in the Arabian Peninsula, which saw increased fertility due to climatic shifts. While these claims are debated, the correlation between volcanic cooling and societal upheaval is compelling. The 536–540 eruptions marked a pivot point, ushering in what some call the Dark Ages, a period of economic stagnation and social turmoil in Europe. Scandinavian elites buried gold hoards, possibly as sacrifices to appease the gods and restore sunlight, reflecting the desperation of the time. The volcanic winter's ripple effects were felt globally, with Chinese records noting crop failures and Indonesian texts describing atmospheric anomalies, suggesting a truly global catastrophe. Unlike Vesuvius, which left visible ruins, or Santorini, tied to the romanticized fall of Minoan civilization, the 536 eruptions lack a single iconic volcano to anchor their story. Their sources are uncertain, scattered across continents, and their impacts were diffuse, affecting climate rather than burying cities in ash. This diffuse nature, combined with the lack of precise historical records from the 6th century, has relegated the event to obscurity. The term Late Antique Little Ice Age was only coined in 2016, reflecting how recently science has begun to unravel this mystery. Moreover, the 536 event occurred during a transitional period between antiquity and the Middle Ages, a time of fragmented records and political chaos. Unlike the 1815 Tambora eruption, which caused the year without a summer and was well documented in the 19th century, the 536 eruptions left no clear cultural narrative. Their story was pieced together through modern paleoclimatology, not through enduring myths or monuments. This scientific rediscovery highlights the power of interdisciplinary research, combining history, glaciology, and climatology to resurrect forgotten events. The 536 volcanic winter offers critical lessons for today's world, where climate change is a pressing concern. Volcanic eruptions remain a wild card in the climate system, capable of causing sudden, unpredictable cooling. The 1991 eruption of Mount Pinatubo cooled the Earth by 0.5 degrees C for 3 years, a reminder of volcanoes' power. While human-driven CO2 emissions dominate long-term warming, volcanic SO2 emissions can cause short-term cooling, potentially disrupting agriculture and economies. The 536 event shows how even a 2 degrees C temperature drop can trigger famine and societal stress, a warning for our interconnected world. Monitoring remote volcanoes, like Zavaritsky in the Kuril Islands, which caused a similar cooling in 1831, is challenging but essential. Many volcanoes remain poorly studied, and their potential to alter climate is underestimated. The 2010 Eyjafjallajökull eruption disrupted air travel but had minimal climatic impact. A larger eruption, like those in 536, could be far more disruptive. Scientists like William Hutchison emphasize the need for a coordinated global effort to monitor volcanic activity, especially in regions like Iceland, where melting glaciers due to climate change could increase eruption risks by relieving pressure on magma chambers. The 536 event, also underscores the vulnerability of societies to sudden climate shifts. Today's globalized food systems and dense populations could amplify the impacts of a similar event. Crop failures in one region could cascade through supply chains, causing price spikes and shortages. The plague of Justinian highlights how climate stress can exacerbate disease, a concern in an era of emerging pandemics. Understanding past volcanic impacts can inform climate models and disaster preparedness, helping us anticipate and mitigate future risks. Europe's forgotten climate catastrophe of 536 CE was not just a geological event but a turning point in human history. Its eruptions, likely from Iceland or a tropical volcano like Ilopango, plunged the continent into a volcanic winter, triggering famine, plague, and societal upheaval. Modern science has resurrected this story through ice cores, tree rings, and climate models, revealing the fragility of human societies in the face of natural disasters. While the exact volcanoes remain elusive, their legacy is clear. Climate disruptions can reshape civilizations. As we face modern climate challenges, the 536 event is a stark reminder of nature's power and our need to prepare. By studying this forgotten catastrophe, we can better understand the interplay of volcanoes, climate, and society, ensuring we're not caught off guard by the next sleeping giant. Let's remember this hidden chapter of Europe's past, not just as a cautionary tale, but as a call to action for a resilient future.